Okay, let's dive in. Welcome to the deep dive. We've got a fascinating subject today, 3I-8 It's the third interstellar object confirmed to, well, swing by our solar system. And our mission is really to figure out why this particular comet is causing such a stir in astrophysics.
Well, it's shaking things up mainly because of how it's moving and what it's made of. It was discovered July 1st, 2025, and it's just screaming through space. We're talking 210,000 kilometers per hour.
Wow, that fast.
Yeah, it's the highest speed we've ever clocked for anything visiting our system. So that pretty much confirms it didn't come from around here. It's definitely from outside our stellar neighborhood.
So the speed tells us where it came from, more or less. But the real deep dive, I think, is the weird stuff it brought with it. The chemical baggage, you could say. It's
Yeah.
just not acting like a normal comet.
Not at all. And its path, well, its trajectory tells us this is just a fleeting visit. It's on a highly hyperbolic orbit. Eccentricity 6.137 for those keeping score.
Which basically means goodbye forever.
Exactly. It's not bound by the sun's gravity. It came in, it's swinging around, and it's heading back out. It will never return.
Okay, so a one-way ticket. It already passed its closest point to the sun, perihelion, right? Back on October 29th.
That's right. And right now, early in November, it's already heading outbound. It's actually behind the sun from our perspective, so we can't really see it for a bit.
But people might get a chance later.
Yes. The closest approach to Earth is coming up on December 19th. It'll be about 1.8 AU away. That's 1.8 times the Earth-Sun distance. So absolutely no danger to us. Let's be clear on that.
Good to know. But seeing it, probably not easy.
No, it's going to be faint. Magnitude 12 to 18. You'll definitely need a decent amateur telescope, like 10 inches or bigger. Best viewing window is probably mid-November through mid-December.
Right, so it traveled light years to get here. What did it bring? You mentioned the chemistry was weird. What did James Webb find?
Okay, so the first big surprise is the COU, carbon dioxide. There's an incredibly high ratio of CAUU to water ice, somewhere between 7.6 and 8 to 1.
Wait, 8 parts CO for every 1 part water? Isn't that backwards for a comet?
Completely backwards for our comets. Comets in our solar system are mostly water ice. This suggests 3I at Hyli's formed way, way out in its home system, likely beyond the Kyoto ice line, where it's incredibly cold, colder than where our comets formed.
Yeah.
It implies, a very different planetary
A
nursery.
different recipe for making comets. Okay, that's weird enough. But then there's the nickel, right? That's the real head scratcher.
That's the really baffling part. Astronomers detected atomic nickel vapor coming off the comet. But here's the thing. It was detected when the comet was still super far from the sun, like almost 4 times farther out than Earth is, 3.88 AU.
And nickel normally needs heat, right?
Yeah.
A lot of heat to vaporize.
Exactly. Thousands of degrees. You'd expect that close to the sun, not way out there where it should just be frozen solid. And it was shedding about 4 grams of nickel per second, but weirdly, with no corresponding iron vapor, which you typically expect if rock was sublimating, it just doesn't fit the standard picture.
So how is nickel boiling off in the deep freeze of space?
Well, the leading scientific idea, the hypothesis, is that the nickel isn't pure metal. It might be bound up in some kind of special organic molecule. Something like nickel tetracarbonyl is one suggestion. These molecules are much more fragile. They can break down and release the nickel atoms at much lower temperatures when hit by sunlight.
Ah, okay. So it's like the nickel is in a low-temperature package deal. That makes some sense. But the weirdness doesn't stop there, does it? It also looks strange.
Right. It had these rapid, unexpected brightening events. And near perihelion, it appeared distinctly bluer than the sun. Comets are usually kind of dirty brown or reddish. Blue is unusual.
So you've got weird chemistry, weird behavior. Naturally, that leads to some more exotic speculation.
Indeed. All these anomalies, the nickel, the blueness, the brightening, even its path being kind of close to the plane of our solar system, led some, notably astrophysicist Avi Loeb, to, well, speculate. He suggested publicly there might be, I think he said, up to a 40% chance it could be alien technology.
Okay, a 40% chance of alien tech. That's a bold claim. But we need the balance here. What's the official word?
Right. The strong scientific consensus is that this is a natural object. It's weird, yes, but likely explainable through natural, though perhaps unfamiliar, chemistry and physics. NASA's acting administrator, Sean Duffy, explicitly stated they see no evidence it's anything other than a natural, unusual comet.
So, not aliens this time, but still incredibly significant scientifically.
Absolutely massive. I mean, 3I is basically a sample delivered to our doorstep from another star system. It gives us a unique peek into how planets and, well, comets form elsewhere. And there's speculation this thing could be incredibly old, maybe 3 billion years older than our own solar system, which is already 4.6 billion years old.
Wow, potentially billions of years older than the sun itself. That age, plus the high COO, the weird nickel, it paints a picture of really diverse cosmic building blocks out there.
Exactly. It shows star systems can be chemically very different from ours.
So here's something to think about. If 3ATLS really is that ancient, billions of years older than our sun, what other primordial materials might still be locked deep inside its core, stuff preserved for eons that could, challenge everything we thought we knew about matter itself as it heads back out into the dark?